Greetings everyone. In this week's ML and AI safety update, we hear about Paul Christiano's views on OpenAI's main alignment strategy. We check out some of the second round of the inverse scaling prizes winners, and we look at the projects from the mechanistic interpretability hackathon from this weekend. And stay tuned until the end for some unique opportunities in AI safety. Reinforcement learning from human feedback, or RLHF, is one of the most applied alignment research theories out there. Its history started in 2015 when Paul Christiano introduced it in a blog post. The idea is basically that we train models not just to imitate humans, but also to act in ways that humans would evaluate as good. This basic idea has resulted in years of research from OpenAI and are one of the main principles behind ChatGPT today. 2 days ago, Christiano published a piece evaluating the impact of RLHF as a research field in alignment, and the speed up of AGI versus the progress on alignment in general. He thinks the project has been net positive, and that replacements that work as well in practice, for example imitation learning, would have been implemented in its place unless RLHF was developed. Additionally, Christiano counters arguments from the AI safety fields, mentioning that RLHF is, in fact, safer than alternative and showcases the risks of ML systems without the necessary scale-up in AI technology. Additionally, it's not an inherently unique capability increase, and it's able to produce realistic examples of some of the deeper problems we see with AI, becoming a boon for alignment. The Inverse Scaling Prize has found its second round winners in a challenge to find tasks where larger language models such as GPT-3 will do worse than GPT-2. These are generally hard to find, but they are very important to identify to figure out which abilities will fall and fail in larger language models as we scale up our technologies. The 7 winners of the second round have all used quite unique and novel methods to get there. So, for example, modus tollens is a task to identify if a statement is true or false. An example might be, if John has a pet, then John has a dog. John does not have a dog, therefore John doesn't have a pet. Is the conclusion correct? Surprisingly, larger models become worse at identifying if the answer is yes or no to if the statement itself is correct. Another interesting example is the memo trap that shows that larger models have a tendency to end famous quotes with the famous quotes ending, despite explicit instructions otherwise. So, for example, ending a quote and saying that it should end it with a specific word will make it just still end it with the famous quotes ending. And this makes it, for example, replicate bias quotes such as from the Jim Crow legislation and from homophobic Bible verses, as the authors note. Prompt injection is another method that's been used, which works to input a malicious prompt injection that sort of circumvents the instruction that has been given until then. And interestingly, medium-sized models actually are the most prone to these textual overrides than larger models, and it shows a performance over model size that is U-shaped instead of inverse scaled, which inverse scaled, again, just larger models doing worse. I recommend checking out the other 4 winners in their report on the round 2 projects as well. The 4th Alignment Jam ended this Sunday with 15 amazing projects submitted. It was on the topic of mechanistic interpretability, where we try to reverse engineer how neural networks process input. Since neural networks learn algorithms from the training data, we can actually try to find the specific algorithms they've learned for specific tasks within the network. You can watch the ending ceremony with presentations by 3 of the 4 winners, but here's a short summary of the winning projects. So the first prize went to Rediscovered and Neuron by Miller and Neo, and they used the Transformer Lens library to find how an MLP neuron, so a multi-layer perceptron, or these like linear layers within a transformer in GPT-2 large, how they predict the token an. So the token again is a word, and an is just an apple. And it really dives quite deep into how this circuit works and when it activates using activation patching, ablation, and other methods from the Transformer Lens library and from alignment research. The second winners were Mathwin and Couleur, who used the automatic circuit discovery tool from Arthur Conley to identify circuits for gendered pronoun identification. It's a wonderful example of using these tools we have available to automatically identify circuits and understand them in depth. Michel Weimann-Lo created a new way to identify feature neurons automatically by identifying which tokens neurons activate for and automatically generating descriptions for what they basically for what they do. In this way, we can get descriptions of most neurons in a smaller network within hours just using this algorithm. And the Mental Leap team found that the embedding space for prompt tuning, which is a specific technique and it gets a bit advanced if we jump into it, is convex. What this basically means is that we can add multiple tokens together as a replacement for another token for a specific task. And it was tough deciding on the winners together with Neil Nanda and the Mechanistic Interpretability Hackathon, so we really recommend that you check out all the other projects as well. And there are some amazing ones, for example, using methods from biology, compiling transformers, interactive apps, and latent knowledge identification methods. So a lot of very interesting stuff. But jumping to opportunities, with the help of AGISF and AI safety support, we're sharing some of these opportunities. The deadline to join a biology and social systems fellowship for AI safety is coming up in 10 days. It's called the PIBBBS. And the Effective Altruism Global Conferences are coming up, with a big one in London in May that you can actually get free tickets to if you apply today. And there will be a lot of AI safety interested people at this event, but also in the Bay Area one coming up soon. And the Alignment Awards competitions are a great way to engage with some of the AI safety theory and some of the AI safety applied space. And it comes with a $50,000 prize pool, so it's also a good opportunity for you to maybe get into the field if you win. And there's two challenges. One is a challenge on generally making AI systems generalize well beyond their training set, so making sure that they don't misalign when there's a new type of example that comes up. And the other is making sure that they can be changed or updated even after they've been deployed or after they've been trained. One thing that OWL-HF is actually a bit of an answer to, but this challenge goes a bit deeper. And thank you for following along for this week's ML and AI safety update, and we'll see you next week. Goodbye.